This is exam 2. This is physics 202, spring 2011. Multiple choice first. Which of the following equations for this circuit is correct? Let's just start going through them. I have minus 6. That means that I'm going in this direction. Minus 8i. So already that's wrong. Then I have 6 minus 8i. So I'm going in this direction. 6 minus 8i1. That's correct. Plus 2i2 because I'm going against the current. Minus 12. Minus 4i1. All right, so it looks like B is the answer. 2 pieces of copper wire the same length. The diameter of wire A is twice that of B. So RA is equal to twice RB. That means wire A is bigger. That means that the resistance, the diameter of A is twice the diameter of B. That means that RA is less than RB. And because the area is equal to is proportional to the diameter squared, that factor of 2 turns into a 4. Since it's smaller, it's 1/4. So the answer is C. Which light bulb in your house draws more current, a 40 or 100 watt bulb? Well, P is equal to VI. The higher the power, the higher the current. So the brighter one, that is the 100 watt bulb. Following circuit. What's the equivalent resistance? Now the numbers on these were pretty simple, so I didn't really expect you to do many calculations. But to find the equivalent resistance, you have these 2 resistors. They can be replaced with one resistor. That's 1 over 1 over 2 plus 1 over 2, which is 1 ohm. Right, so that's a 1 ohm resistor. And then combined with this resistor gives you 2 ohms. So when you simplify it, you get 2 ohms on top, 2 ohms on the bottom, so 12 volts. And then this, which we've already done, 1 over 1 over 2 plus 1 over 2 is 1 ohm. So the answer for number 4 is A. For this circuit, what is the potential across R3? All right, we know we have 6 volts here, 6 volts here because it splits them. Similarly, you're going to have 6 volts here, and you're going to have 6 volts across these 2 resistors because they simplify into a 1 ohm resistor. And because they're in parallel, R3 and R4 have the same potential, so it's 6 volts. Number 5 is C. Circuit above, if R3 is removed from the circuit, what happens to the current through R1? Nothing's going to happen. It's going to remain the same. It's like your household circuit. It's in parallel. And if you remove a resistor in your house, coffee maker or whatever, it doesn't affect the hairdryer in the bathroom. Consider the above circuit. Which resistor has the least current through it? Is it R1, 3, or 5? All right, well, R1, 3, or 5. 1, well, we can just look at the numbers here. So we have 6 amps going here. 6 amps going here because I have a 1 ohm resistor, so that gives me a total of 12 amps, and it splits evenly because I have the identical resistors here and here, so it splits evenly. That means I get 6 amps going through R1. This 6 amps, however, is going to split into 2 pieces, into 3 amps and 3 amps, and then come back together and have 6 amps. So that gives us R3 as 3 amps, whereas R1 and 5 has 6 amps, so it's R3. That's B. Which of these statements about a household circuit is true? All right, household circuit is a parallel circuit. This statement is not true. They operate at the same voltage. This statement is not true. The potential across each device stays the same. So it's a good thing. Circuit breaker turns off if IN. Okay, this is not a circuit breaker. This would be a GFCI. GFCI turns off if IN is greater than I out. The circuit breaker, remember, limits the total current to a particular value, so it's just 1. That's answer A. Which of these best describes why some materials are permanent magnets? Right, well, all these things are true, but which describes why they're permanent magnets? Well, it's not because they're at the center of the Earth, because you can make permanent magnets on the surface of the Earth. It's not because they're made of metal, because not all metals can be made into permanent magnets, copper, for example. These materials contain charges. All materials contain charges, so it must be B, that the magnetic domains of these materials are all lined up. If you recall in class, drew a permanent magnet, the magnetic fields of the individual atoms are all lined up in the same direction. This figure shows a loop of wire through which current flows. The magnetic field of a permanent magnet. Our magnetic field goes in that direction. I want to know what direction does the loop initially turn. So if I let my fingers, let's just take this side first, let my fingers go in the direction of I. They fold towards B, which is to the right. That gives me a downward force. Similarly, I'm going to get an upward force there. That's going to cause a clockwise rotation. Positive charge is traveling towards the wire as shown. Initially, there's no current. What direction will the charge travel when the current is turned on? All right, when the current is turned on, we get a magnetic field into the page there and out of the page there. So when it's turned on, the force that's felt by this particle, let my fingers go in the direction of V. They fold towards B, so it's going to be, the force is going to be felt downwards. That's option A. Negative charge enters the magnetic field as shown. What direction will it feel a force? All right, so V is up, B is out of the page. That tells you that it should be right, but notice it's a negative particle, so the force is to the left, is the opposite of what you find for the right-hand rule. Number 13, you have two wires. You want to know what is the direction of the magnetic field at a point equidistant. All right, but due to this wire, I make a magnetic field that is out of the page. That's due to this wire on the left. And due to the wire on the right, I make a magnetic field that is into the page. So these two are opposite directions. They're the same magnitude, so they both cancel out and give you no magnetic field. That's option E. These are the types of light in the electromagnetic spectrum, or types of light, not a V. They're listed alphabetically, arranged in order. Alright, well, the lowest energy is radio, then microwaves, and then ultraviolet, and then gamma rays. So radio, microwaves, looks like D. Number 14 is D. This figure shows the path that light travels through three different materials. Which of these describes the relationship? Alright, well, light is traveling from N1 to N2. It travels faster in N2. That means that N2 is less than N1. And then it travels from N2 to N3, and it travels slower in N3. That means that N3 is greater than N2. Well, let's just see if that's enough to answer the question. So N1 is greater than N2. That gets rid of B and C. And then N3 is greater than N2. Right, that gets rid of D. So the answer for 15 should be A. By the way, you could also say that N3 is greater than N1. In this figure, light travels from water to glass. What must theta 1 be for the total internal reflection to occur? In this case, I'm moving from a low index, that is n equal to 1, to n equal 1.5. And that means that the ray is going to move towards the normal. So total internal reflection, which is when it moves completely away from the normal, will never occur in this situation. Select the words that best complete this sentence. Huygens proposed a theory that described light as a wave based on refraction. So let's see, that is B. Number 17 is B. Number 18. Number 18, this figure shows an incoming ray. This angle is 30 degrees. If that angle is 30 degrees, this angle is 30. So this angle is 60 because the total is 90. This angle is going to be 30 because I have a little triangle there. I have 60 and 30. Those two angles have to add up to 90. So that gives me this angle by the law of reflection to be 30 degrees. So number 8. Let's see, did I do that right? No, I'm sorry. This is 60 degrees. And so this is 60 degrees. So option C, number 18. All right. Let's see. You might have picked different equations for this, but I'm just going to show you the ones that I did. I chose I1 to be here. Chose I2 to be here. I chose I3 to be there. Then my equations, I'm going to pick this junction. My equation number 1 is I1 plus I3 equals I2. My second equation, let's see, it looks like I chose the left loop. It looks like this. I have 12 minus 2I1 plus 8I3 minus 6 minus 3I1 equals 0. And then for my third equation, actually I'm going to go ahead and simplify this one a little bit. I get 6 minus 5I1 plus 8I3 equals 0. And then equation 3, looks like I chose the right loop. 6 minus 8I3 minus 4I2 equals 0. And then I solve equations 2 and 3b, 2 and 3 for I1 and I2. So I'm going to list this. This is solving equation 2 for I1. I1 is equal to minus 6 minus 8I3 over negative 5. Look, I can just make these all positive. And then I can solve equation 3 for I2. It's going to be 3/2 minus 2I3. So notice I have two equations for I1 and I2 that are both in terms of I3. Then I plug those in to equation 1. Plug those into equation 1. I'll call this equation 1b. I'm plugging 2b and 3b into equation 1. So I have I1, which is 6/5 plus 8/5 I3 plus I3 is equal to 3/2 minus 2I3. And then if I solve this for I3, I'm going to leave the algebra for you, but I find that I3 is equal to 0.065 amps. Notice that it's positive. That means that I chose my direction correctly, so it's up. And then I just plug that value in to these equations for I1. And from equation 2b, I get that I1 is equal to 1.3 amps. And it comes out positive, so that means that it's clockwise, or also except it's up. And then also I2 is 1.4 amps. That's from equation 3b. It comes out positive as well, so I chose it correctly. So I2 is clockwise. I also chose down, or accepted down. All right. If you did it by the matrix method, several students did that. I gave you +3 points. And if you missed up on the algebra, I usually only counted off a couple of points. But primarily I was looking at these equations. I generally count them as 5 points each. And that left sort of 10 points distributed elsewhere in the algebra, though. Unless you just didn't do the algebra at all, I didn't count off that much. All right, number 20. Most people got this. I just want to know the force in vector notation on this charged particle. The force is equal to QV cross B. All right, the Q is 2 coulombs. The V is given as 3J minus 3K. And then the magnetic field is 2I minus 4J. So I do foil. First is 3 times 2, that's 6, times J cross I. Outer is 3 times -4, that's -12, times J cross J. Inner is -6, K cross I. And then the last is 12, K cross J. Okay, and then I want to simplify this. J cross J goes to 0. I want to know what is J cross I. It's I, J, K. J cross I, using my right hand rule, fingers in the direction of J, fold towards I, is negative K. So this is going to be 6 times negative K. Minus 6 times K cross I. K cross I is J. That minus 6 times J plus 12 K cross J, which is K cross J is I, positive I. Wait, no, I'm sorry, negative I. Alright, so that's negative 12K minus 12J minus 24I. Largely people miss the signs on this. I counted off, so I didn't count off a whole lot for that. Okay, for the laser traveling, a number of people got this right, but also a number of people got it wrong as well. So your first step is you want to find out what is the refracted angle. Our theta 1 is 30 degrees, and let's see, when we move from water to air, you're going to move away from the normal. This is not really drawn to scale. I'm going to sort of try to draw it to scale a little better. Alright, and then the laser strikes up here. So my first step is I want to figure out what is this angle. And so I say N1 sine theta 1 equals N2 sine theta 2. N1 is, for water, 1.3 sine of 30 equals 1 sine of theta 2. If you solve this for theta 2, you find that that angle is 40.5 degrees. Right. That was sort of the largest part of the optics part of the question, and then it was just a matter of geometry or trigonometry, if you will. So I can say that this angle is 90 minus 40.5, and so that is 49.5 degrees. And then I want to define a couple of things. Let's see, I'm going to call this x1, this distance, to be x1, and then I'll need to find this distance, which is x2. I'll call this distance y1, and then this is y2. So my total y is going to equal y1 plus y2. I need to figure out what all these values are. I have to find x2 in order to find y1, and in order to find x2, I have to find x1. So first, let's just start with x1. I have the angle 60, and I have, if I look at that triangle, this angle is 60 degrees, this is x1, and this is 0.75. So I have the adjacent and opposite sides, so I can use my tangent. Tangent of 60, let's see, TOA, is opposite over adjacent. That's 0.75 over x. That's x1. And so x1 is equal to 0.433. That tells me that x2 is 1.3 minus 0.433, which is 0.867 meters. And then I want to find y1. So if I draw a triangle here, this is y1, this is 0.867, and this angle is 49.5 degrees. I want to find y1. The tangent of 49.5 is y1 over 0.867. And so y1 is 1.02 meters. y2 is 0.75 meters. So my total y is 1.02 plus 0.75, which is 1.77 meters. So you got some numbers that were slightly off, but just because of averaging, but I think, or rounding off, I didn't go off for that. All right, describing your own words how an electric generator works. Be brief. Largely what I was looking for, and sometimes I got a lot more than this, but was that a generator, apply a force on a wire, or a coil of copper wire, which sits in a magnetic field. And this causes a current to flow in a wire. I accepted a wide variety of those. Some people actually said that instead of moving the wire, you move the magnet, which is also true in different types of generators. Instead of moving the wire, you actually move the magnet around the wire. So that's similar to like the wind turbines that we saw in class. There are the answers to multiple choice.